I'm going to do a bit of a video regarding Visual Studio and Windows Git, unit testing, and some other things. I think it'll be helpful for those who are recently joining RadFormation to avoid some pitfalls and hopefully be able to uh, enjoy using Visual Studio a little more, and as well as Git with Windows. Git, of course, generally is a command line tool. You can get Git here. Obviously, I think you guys already have it, I'm sure. Tortoise Git is a Windows shell interface that I have used since 2009 that I really like. And the cool thing about Tortoise Git is that basically it adds these command line, or not command line, but Windows Explorer integration where you can easily do some things. In fact, I was just going to add a bunch of things to basically what was an empty Git repository, um, so that we could check them in to this Git repository. So I'm just going to select them all and get Tortoise Git add. You can see here it tells me which files are going to be added. Um, and it looks like those are all correct. So this git ignore file, I don't know how familiar you guys are with Git, but it's really useful uh, for Visual Studio. You'll notice that this git ignore file is included in basically all RadFormation's Git repositories, or should be. And it basically tells Git to ignore certain types of files and locations and so forth. So um, it's really useful because if I didn't have that, then these bin and object files that are generated every time you build would have been added. Well, I could have unselected them, but it's a much more efficient way to check in your code. You'll notice I didn't check in this packages um, folder, and I'm going to show you why. But I'm actually not done processing this, so when I'm ready to actually commit this to the repository, git commit allows me, I go to always to the top level where the repository is held, and I right click on that and do a git commit. And here I can write the message. This is basically refactoring of this is the Beam data thing that I mentioned to you guys. Uh, Refactoring, added unit tests. It's really important to add good messages. I'm probably not going to give you a good demo of that right now. Let's see, what else should I add? Added output factor table. Though, no, I think I added that last time I committed. So anyway, so all you do is hit commit. It tells you what happened, if it succeeded or not. Then when you push it, so of course Git is local. For when you commit, you have a local copy of the repository, and then you push it to the remote master branch, and I successfully did that. So it's a really nice way to do that. It's cool because if I were to make any edits on something, for example, I'm just going to add some garbage in here. You can actually see which files have been edited in the Windows Explorer window. When you go to git commit, it shows you everything that's been changed. You can double click it and it'll open up a merge thing. You can hit next difference and previous difference and select this text block, right click it and use this text block or use this whole file. So, I mean, you can really do a lot of cool things. It makes it a lot easier to do things. So I like Tortoise Git, so I'd like to recommend that to you guys. The other thing you can do, of course, is right click it and revert, or from the Windows Explorer window, any top level it actually would revert everything. So I go to Tortoise Git, revert, and it would ask me which ones I'd want to revert, and I'd select them, and it would succeed. So I fixed my um, garbage that I added. So anyway, so what else did I want to show you? Let me look at my notes here. No, let's close that. Okay, so NUnit test driver extension. So unit testing is something I hope you guys have heard of, but it's something you may not have done a whole lot of. I know I didn't do a whole lot of it until I started working professionally, because it's something a little bit overhead, a little bit intimidating at first, but really it's pretty awesome if you are able to have some discipline, and I'm not the best at it myself, but I think that it's worthwhile to go over how it works. When I talk about NUnit test driver extension, that's actually something to do with these extensions and updates. What it can do is it gives you this Test Explorer window where after we build our project, um, we have these test projects. I'll show you this beam comparer.test, and I'll show you how to make one of these projects and how to make a class. In fact, what I'm going to suggest is that you go through this code yourself and kind of see the different examples. I've tried to comment it of how you can make some tests. But in any case, this Test Explorer window, which to make it appear, you go to Test, up here, Windows, Test Explorer, and these are all the tests that are identified. Now with C# and .NET, it's kind of cool because there's these attribute tags. They're kind of like, what is going on here at first when you first encounter them, but what happens is it basically adds some metadata about the thing that follows it. So you can see this class sample has some metadata because it involving this attribute tag, test fixture. Now, all classes that have unit tests in them should have this text fixture tag because that's what tells the test driver to tag them as containing unit tests. And then every function inside of there that you want to include as a unit test function, you add a test tag to right above the function, or you can even have multiple tags, and these test cases basically you take whatever parameters you provide and plug them into the function and run the function, and then of course report results. So this Test Explorer is really cool because all these tests you've developed, you hit run all, and it'll go through and test them all, and if one fails, for example, this expected, so, excuse me, the test 1 and test 2 are 5 and 6. Expected, I'm going to change to 11. If I run that test, of course it's going to fail, and it's going to tell me what point. In fact, I click it, and it'll take me to the line that failed. This assert failed. And so anyway, I'm going to give you kind of a brief overview on unit testing and stuff. So let me fix that issue, and now of course the test will not fail anymore. You can see it's now a question mark because it was changed, and I run it and it passed. So unit tests are really nice for especially regression tests to see if you screwed something up that now what was working wasn't working. People in software development tend to talk about how much test coverage they have on their source code, which means how many lines of code are covered in some kind of unit test. And it's kind of, I don't know, part of it's, the test is only as good as how well you designed it. I don't know that that's necessarily the greatest measure of how good the test is, or how good their unit tests are. But in reality, it's just a matter of trying to identify all the edge cases and design test cases for them to test your functions to see if they're working right. So anyway, the way that you get this Test Explorer to work with its NUnit is the unit testing framework that we use. There's different ones, but NUnit is the one that I think we should just commit to, given that our other projects use it. So you go to Extension and Updates. It'll pop up a window or crash. No. So you go to Online because you're searching online. You don't have it installed. You search the Visual Studio NUnit. Oops, NUnit. And this is the one you want, NUnit 3 Test Adapter. So you double click it or do whatever and install it, and close out and restart Visual Studio. And you should be able to go to test settings, Windows and Test Explorer to pop this up. And you kind of have to click it to open and close it. But the other thing you got to do is you got to get in your test project. I'm going to actually pretend as if, in fact, we can just make a new test project. So one of the things with Visual Studio that you have to get used to is the project hierarchy. And it can be a little bit annoying. Like for example, so I like to right click on this solution and open folder as a way to get there. But if I wanted to rename this folder, Beam Data Comparer, it's kind of annoying. Like I would have to look up again like the best way to do that on Stack Overflow, because this reference here, you can see if you click on it in the solution, the project folder is pointing to a particular location, and it's not easy to just like change it. It's better to, well, basically what you'd do is you rename the folder, then you'd remove this project, and then you'd right-click the solution, add existing project, and you navigate there. So I mean, there's kind of some goofy things that hopefully aren't gonna get you too caught up with it. Yeah, I would suggest just whenever you have like something you want to do in Visual Studio that doesn't seem to work out easily, just Google it ASAP because sometimes it's not that intuitive. So anyway, I'm going to add a new project, and you can see there's these unit test projects. That's why it has this lab thing. I'm going to call it demo.tests. We have a convention in Radformation, at least in our other projects, to add .test, or not tests, .test afterwards. And so just hit OK, and you can see the now. Oh, in fact, we also actually tend to put them not in the base directory. So I'm just going to delete this. Going to delete. Oh, you need permission. I think that's because it's open. I'm going to delete it here, and then we'll try it again. There we go. But rather inside of a test folder. So Beam Data Comparer is actually, or .test is actually inside a test folder, which is kind of weird. I'm gonna, let's see, add new solution folder. And that folder, I'm gonna remove this. So this is showing you some kind of some of the goofy things. So here I am in the Beam, there we are. Let's see, Beam Data Comparer. No, tests, Beam Data, there we are. Okay, so now we've isolated them into a test folder. So you see the kind of goofy things you had to do there. But anyway, I'm gonna add a new project to the folder, and it's gonna be called demo.test. The other thing is that this hierarchy doesn't actually show you everything in this folder. Like you could have a bunch of, in fact, if I open folder in File Explorer, you could have a bunch of other files in here, and it wouldn't show up in here. It only identifies things that have actually been linked to the project in there. So anyway, so this test, you can see it has some Visual Studio test platforms. So it's using, instead of text fixture, it's using test class and test method. But we want to use test fixture and test, what was it? Just test, all right? But you can see it obviously doesn't know what test fixture and test are. So one of the things that I wanted to demonstrate to you was references. References are really important, obviously. And there's kind of a hierarchy of references. So this project, it's missing a reference to the NUnit library, because the NUnit library is the one that actually has these attribute classes that you can apply. So without it, you can't use it. So what you can do is come here to references, and if you have a DLL anywhere on your computer, you could add that, but we don't. So, but what I wanted to show you was NuGet packages. So NuGet is basically kind of like a GitHub for libraries for .NET, I guess you'd say. But it's like a marketplace almost. So you hit browse and you would type NUnit, and you would grab this NUnit here and install it. And it seems that I think I've done it here. You can actually see the reference NUnit.framework here. And double clicking it obviously isn't super helpful, but right click here, manage NuGet packages. So the installed ones, NUnit, is installed in my other test project, but it's not in my new test project. So that's one of the things, every time you make a new project, if you're going to do that, you might need to fix your references. So I'm going to do this NuGet thing. We're going to add NUnit, install it. It's that easy. It's going to ask you about this. Yes, to all. That's fine. Okay. So it's installed. Now my unit test still is having problems. What's up with that? Well, what happens is you still have to like give it a using statement using NUnit. But the cool thing I want to show you guys, and this is true with any time that you have a reference that's broken, is if you highlight it or if you're on the end of it and you hold down Control and press period, it'll give you a bunch of hints. And if it's available, the using statement, if it has something that's already available that it can use, it will appear. So you just click it, and usually, I don't know, occasionally like it doesn't do it, you have to do that again. But anyway, it just pops in, and there you go. It's pretty awesome. So the other references issue I wanted to show you was, suppose I wanted to test something from my Beam Data Comparer file. Let's see. Something from the services, correlated data sets. Let's do this. So I want to test this. So with Visual Studio 2017, this used to not be the case, but I can just type that, do that control period, and it will actually say add reference to Beam Data Comparer, and it will add a reference to the project. That's pretty awesome. Actually, I used to not be able to do that, but now what I would do historically is go to references, add a reference. So you can either browse to like a DLL if you had a DLL of my project, but that's not ideal because what if I change my project? I don't want to keep updating the reference. So what you do is the projects, solution. I would just hit the checkbox next to Beam Data Comparer. That would accomplish the same thing as having done what I was doing. But you can see now when I press Control period, it just says using Beam Data Comparer because I already have the reference in the project. So then I could use this function however I want, right? So references are, like I said, if it's having errors because it can't find certain classes or functions, and then control period might give you some hints, but it might be a NuGet package you're missing, or it might be that you're not referencing another project in your own solution. And I gotta warn you, sometimes it just gets like screwed up, and you just need to do this clean solution, which basically unbuilds everything and then rebuild everything. And then if that doesn't work, close Visual Studio, pop it up again, because sometimes it gets run around in circles somehow. So anyway, that's adding references. The other things I want to show to you, so suppose I did this correlated data sets dot compatible types. I'll just pass in null parameters. Okay. Two things that are like huge in Visual Studio for me are, one, if you right click, you can see all these options, but one of them is go to definition, and the hotkey by default is F12. This one's huge. Like if I'm looking at someone else's code and even my own code navigating around, this is so helpful because you just highlight the thing you want to navigate to, the definition of, you press F12, or you right click and do whatever. And here's the definition, and so you can drill down and what other curve types are there? I would double click curve type and press F12, and now I can see all the different curve types. It's like super nice to. And so this back button is really handy too if you want to get back to where you were. So I drill down into curve type, back button, or holding Control and press minus. Oh, Control minus is my pause button for my recording. So sorry, I can't show you. So anyway, you just click it or press Control minus. Really nice. The other one is find all references. This is super nice because like if you are worried about what's going to happen when you start to tinker with a certain property or where it's used, you just press Control or Shift F12, or of course you can right click here and find all references, and you can dig around and see wherever it's used in your entire solution. And yeah, really handy. The other one, of course, is rename. So Control R, takes two hotkeys, but if I wanted to rename this to Boogeyman, then it would. And then Control Z undoes it, of course, but it would not only rename it, but it would rename it everywhere. So you see Control R, test 1, 2, 3. It's test 1, 2, 3 everywhere that it's used. Undo it, undoes it everywhere that it's used. The other thing, I don't know, I mean, someday you might regular expressions, they're just amazing. If you don't know what they are, you really should look it up and kind of tinker with it for a couple hours, because like um, find and replace with regular expressions is extremely powerful, and it's extremely powerful to program with regular expressions whenever you're working with text. This will save you tons of time, and it's fast and all that. So let's see. I think those are the main things there. So I wanted to show you about debugging in Visual Studio briefly. Um, so debugging is really nice in Visual Studio, in my opinion. So this, I'm going to actually be linking this video to you with a link to this repository. But in .NET WPF framework, which is a user interface framework, it's really pretty straightforward to use in the naive way. There is a design pattern MVVM that is a little bit more, it takes a little bit getting used to, but can be powerful. Um, but anyway, this project uses it in kind of a naive way, which is fine, I think, for what it does. But anyway, so this main window .xaml, maybe I can go over this real quick. So XAML or XAML is basically XML that specifies user interface. It's kind of nice because you have this like visual way of let's see, search toolbar, all WPF controls. So there's a visual way of like editing stuff. I wonder if I should be able to zoom in. Yeah, okay. So if I wanted to click on this button, it would go to the XML that actually affects that. So I could change the text, boogter, and it changes it on the fly. I mean, you can maybe look around a little bit. I mean, there's not a whole lot that I think in the near term you need to worry about with user interface stuff, but I mean, just to be aware of what you can do. I mean, if I copy this button and paste it again, change its and click and drag it. Oh, it's invalid because there's two buttons that have the same. I'm just gonna, it should be the same, or does it have a name? If it has a name, this name, if the name is a, see, yeah, this is really kind of hacky then, because I'm even just using generic names for the buttons. But anyway, so you can see I just duplicated that button by copying its XML, and I could change the booger man. And you can change the height, and you can change a lot of stuff, and like you can change what the function called when it's clicked is, and it even gives you some hints. So if you open the bracket or the quotation mark, you can make a new event handler, and it'll automatically generate one, and then you could double click on that, um, to highlight that name and press F12, which was what our go-to definition. And here you could, make it do stuff. So pretty neat stuff, really. I mean, the tools are not bad. So I'm gonna undo everything I just did. Anyway, so debugging. So main window. So you can see the way that WPF launches up. It's not kind of the standard main function that you're probably used to with with other programs, with Python and C++. But so this app has a startup URI. This app XAML doesn't have anything in it really, and it doesn't really do anything special. But this startup UI says basically just make a new main window and call the show dialog function, which shows the window until you close the window, and then it's done. So it shows the window, and when it does, it calls the Windows constructor. And in the Windows constructor, you can see it's a partial class. So partial class means that I could have like 5 files that all contain partial class main window and contain functions, and ultimately the compiler would combine it all into one class. But the reason it's a partial class is because this XAML file actually generates a bunch of code that is behind the scenes. You don't have to know anything about it. That handles all this stuff, and then it also combines that with this code. So this is the constructor, this initialized component. All WPF windows require an initialized component. I think all components, UI components, require that. So anyway, you just have to have that in there. But after that, so I'm going to click here or press F9 if you haven't changed your hotkeys, and it adds a breakpoint right there in the beginning. I can press start, or I think it's Shift F5. No, yeah, I'm just gonna press play. Um, and it'll pop up pretty much right away, right into this first line of the main window, and here I am. There's these diagnostic tools. You can actually turn them off. I don't remember how offhand. You can Google it, but um, I don't know that they're super handy right away. They give you some information about, memory usage and CPU usage. But the better thing is with a debugger, there's several things you can do: step into, step over, step out, and and continue. F5 is continue. If there was a certain place you wanted to continue to, for example, I want to continue to this point, I would add a breakpoint there. F9 adds a breakpoint or unadds a breakpoint. And then press F5 and it'll continue to that point. That's a good way to skip a bunch of lines, or like a for loop instead of going through the for loop many, many times. So anyway, one way to really understand what someone's code is doing is to kind of step through it. I think it's especially if it's kind of built in a linear way, which is one of the benefits of kind of doing the naive approach to these WPF things, is because it's a little bit more linear. It's easier to follow, I think, the code than some of the more disconnected, more modular. So there's cost benefit, but anyway. So I'm going to go to this load files function. I press F10 there to skip a step. If I do F11 to step into, then it steps into the function. If I press F10, watch what happens. It runs the function and then goes to the next line, but it doesn't go into the function, at least with the debugger. It does run the function, but it doesn't show you what happens. I'm going to rerun this. I'm going to stop, click the breakpoint there, hit start, and now I'm going to press F11 instead, because I'm on this line. I haven't executed yet. F11, you see it went into the load files. I'm pressing F10, 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 F10. So it's going through the selected files. There's 4 selected files that are passed in as a parameter of strings. It's going to go through each file. It's going to see if it ends with .data. It does in this case. It's a valid file type. I got to warn you that this code isn't super clean. There's a lot of things that could be done to make it cleaner, but certainly. So this is a project that I worked on in the clinic at one point, where basically what happens is the beam data that's exported from the Eclipse treatment planning system is loaded and then compared against measurements we made every year. So anyway, that's kind of the point of this program. But in any case, it actually does load the data in a nice format that I think you could use for these beam data modeling, optimizations and so forth. So anyway, so you step one at a time. This parsed output factor tables. This is a list. One of the things you're going to run into is something called link or linq. You can see system.linq. This is a really nice library that adds basically almost like SQL-esque functionality to any list or collection. So here you see this parsed output factor tables has one object in it. But anyway, it's a list. If I double click in and press F12, it takes me to this binding list output factor table. These brackets, these are basically like C++'s templates. I don't think Python has an equivalent, because Python everything's generic, or I mean it's not strongly typed, so like nothing matters, right? So anyway, but for C++ there's templates. I think it's the same principle, but the idea is that there's they're called generics because it's an object that can operate on a different type. So in this case, a list that contains output factor tables, and this one's a list that contains Eclipse data files. If you didn't have generics, then you'd have to build 2 separate classes that implement all the functions, because it's strongly typed. A strongly typed language, you'd have to build 2 separate classes that do basically the same thing, but contain 2 separate types, right? But with generics, you can build a class that basically, and you can read up on this if you want, but basically the class can support any type, and so all you have to do is when you declare it and make it a new one called a constructor, you just have to specify in brackets the type that applies. And you can have multiple types, like if it's a dictionary that has keys, an integer lookup keys, and string values, and you'd have two types. You'd have int comma string. So anyway, with a dictionary, it's a little different. So, but to continue, let's see. So these functions, I can actually demonstrate to you what happens with these, but we'll come back to it actually. So basically what this function does, though, this load files function, is it comes in, it tries to find files of a certain type or with a name that ends. It checks if it reads all the text, which isn't super efficient, but I don't think we need to be super efficient in this case. Looking for output factor table because all Eclipse files are by default export with the data and exit or last part. So it's either an output factor table data file, or it's like a profile, or beam profile, or a beam percent depth dose curve. So it doesn't contain the output factor table, so it comes into this else statement. It looks at and it tries to make a new data file. I'm going to press F11 to enter this constructor. The constructor initializes all the default values, all the properties, or all the data fields. It pulls in this file path. It will set its file path property, and it runs parse scan data. The parse scan data function, I pressed F11 to go into that. It goes through, it parses a line, or it basically reads all the lines in the file, goes line by line. As you can see, basically it's looking for certain things. It's trying to find a colon. If there's a colon, then it believes it's and I think I thought I wrote, maybe not. I can show you what these look like though. The Beam Data Comparer, there are some sample data files. So these profiles, for example, you can see, let's do these profiles. Oh, that one's messy. Let's do the measured depth doses. Let's do that. So there's a bunch of, like a header. So basically the way I decide to parse this file is I look for colons, and if I'm finding colons, I know I'm in the header. Then the first row I know is like the column legend, field size. So there's nothing in this one. It's comma separated values. And 30 is 3 centimeters or 30 millimeters, 40 millimeters, 4 centimeter field size, 6 centimeter field size, 8, etc. And then on the row legend is depth, so 0 to 3.2 millimeters to 8.2 millimeters. So they got a pretty big step size here, but it's like 5 millimeter step sizes. But that's fine because this is just sample data. So anyway, it pulls in the data and it goes through and does all this parsing. I'd implemented this before I got big into regular expressions, so it's not as it's very brute force-ish. Regular expressions would have made this easier. But anyway, it goes and splits the strings. It stores the data. I'm going to come down to parse Eclipse data block. It parses the data block, which is all the strings, the parsed lines that actually have data in them. If you go in, this one has 400, 100. This one only has 2 columns in it. So the first column has 5 in it. The second column has 100.2 in that line, and so forth. So then it looks for, it just pulls the data out. And ultimately, I'm going to come down to the very end. In fact, this is a good time to do step out, Shift F11. So that brings us back to, that function call. I'm going to turn off that breakpoint, press F10. The output is 5 Eclipse data objects. Inside Eclipse data objects, it has the curve type. These are diagonal profiles. It has what depth it is, the maximum scan chamber measurement, so the maximum value. So if you needed to renormalize it, which some of these may need to be renormalized, the file that it came from, the X values, and the data vals. So X values has to do with the this is a profile, so this is distance from the central ray, and the data vals in this case is the value in percentage of the central ray dose. So you can see that there's these horns. So it's actually looks something more like this is what this data looks like. And this is the central array. It's not drawn well, but anyway, just to give you an idea. So that returns that, and it returns that Eclipse data file object that contains that sampled data. It adds it to this list of parsed data files, and it goes through all the, so every data file can have multiple scans in it, basically. So then I go through each scan and I create point lists. So these point lists are the object that you would probably tinker with if you were using this data, because the point list, you can see each point list type inherits. And if you're not familiar with polymorphism, it's kind of a good thing to understand how it works, but it inherits from this data point list, which inherits from this generic list of points. So list of points, it can contain any number of points. You can add points dynamically. It's not a fixed array, though underneath the hood it actually uses an array. So it's very fast for lookups, and if you add more points to it than it has room for, it will dynamically reallocate and whatnot. So anyway, this generic list is really a nice data structure. So this data point list has most of the stuff I think you'd need, probably the energy, the field. These are all the default values, but the x-axis unit in this case, unassigned millimeters, centimeters, nanocoulombs, coulombs are reading. RDG is reading. Date machine, I mean, these don't really aren't super important for what we're doing, but you can see these are the constructors you call with no parameters, and if you do a colon and then base, it calls the base constructor, the base constructor being the list constructor. I'm going to navigate to the definition of a list. So here's the generic list that's in the .NET framework. You can see the interface, though you can't drill it down into the code, can you? I don't think. I mean, it gives you a summary of them, but I don't think it gives you the implementation. Yeah, it's just the interface. So, but you can, I mean, you can drill down into the .NET data structures and kind of see what's in there to a degree. So anyway, that's so this data list has a list of points. So if I wanted to access, for example, so I'm going to hit stop. But if I wanted to access all data point lists, the 0th element, this is one of these data point lists, but you can see if I do 1, then it's the first element in that index. I can do .count, it gives me the number of elements in that list. And the elements are points, so if I grab that first element, assuming it has one, there's an X value and a Y value because they're points. They're two-dimensional points is what's stored in that list. So that's the values that you'd be tinkering with. So I wanted to come back to LinQ, or link, as some people say. I like to say LinQ, I don't know why. But so if I have a list, any list or any enumerable is something that contains, or that can enumerate elements one by one. You will see quite a bit of times this IEnumerable with a given type. So if I had points in here, IEnumerable points, you can pass that in as so you could have any kind of collection you could pass into, any collection of points you could pass into a function if your parameter was IEnumerable points, and it has what you need to iterate over that list, which is nice. It gives you the flexibility to pass in any collection, that kind of thing. So you might see that in IEnumerable interface there and there. But in any case, so parsed output. So I'm going to take this collection and press dot. IntelliSense is really nice because it shows you basically everything you can do. If you don't see all these functions that I'm going to show you, then you need to have this using system.link, because if you have this using system.link, it actually has some attributes and stuff that add things to the editor, or it has extensions. There's ways you can in .NET add extensions to classes, like an IEnumerable, for example. And these are examples of the extensions you might add. So anyway, one of them is .any. I like that one. That's one I was showing you. So the way you use any is you can see here it's providing a Boolean is the output. List looks kind of confusing, but anyway, this you can see this parsed out or this parsed output factor contains an output factor tables. It's a list of output factor tables. You can see the .ini function is it's telling you that IEnumerable generic because the IEnumerable interface was extended by the link library. Now this IEnumerable, it's a generic one, but so IEnumerable of anything now has a .ini function, and the ini function basically it has a output. So I'll show you what if there's any in it. If you just do this, then it'll return true if there's any elements in the list. But there's another. You can after you open the bracket, it will give you a basically a hint of every function you can call, which is one of the awesome things about IntelliSense as well. So you can see that there's this function. You can pass it a function, and the function has to return a Boolean. So you can see how I used it here. Basically, the function has to be an output factor table is the parameter, and it returns a Boolean. So you can name it whatever, booger, and then you do this. This is like a lambda function. So you're writing a function that doesn't exist yet outside. You could actually use, I believe, functions that you wrote, wherever. But it's really nice to just write the function in the context of where it's being used. So you're trying to find any element of this list, and this booger is the name of the element, or is the variable name that's used to store temporarily the element that you're going to do an operation with to decide whether it's one that should be included in the list. So where booger dot data or energy MV equals 6.0, right? So you're looking for any element in the list. You're naming it booger temporarily as you go through every element. But you can see how it does some programming that if I wanted to build this programming by hand, I would go like for each. So I would do Boolean has booger, no, has 6MV, right? Equals false. For each output factor table, OFT, this is how I would normally do it. In parsed output factor tables, right? I'd have to go through if output factor table dot energy equals 6.0 has 6MV equals true, and then break, so we don't have to go through the rest of the elements because we already know that it's true. That's what you'd have to do otherwise to get this value. But Link has these implementations. You don't have to worry about the implementations. You just, in general, they're good implementations, so you won't have to worry about it. There's other ones like .order by, and then you can order by. I'm going to call each element in the list X as it goes through the X, and orders it by X. X dot energy. Now it doesn't actually change it doesn't change what's in this list when you call this. So what I would do is make a new list of output factor tables, store it in a temporary variable, sorted output factor, right? And then I would call, so this returns, what does it return? It returns an I ordered enumerable. It's an enumerable too, so it has its own LingQ function. So one of them is toList, and you can just turn it into one of these nice generic lists. So anyway, now we have a sorted output factor table that's sorted by energy. And all you had to do was say order by, you give it X represents all the elements as it's iterating through the list to order them. Represents output factor tables that are in this list, and then it's ordering by this. You can see this. This is taking a function, and the key to order by, to compare with is what the function returns. So in this case, we're returning this double floating point number, energy MV, as the key on which to order by these elements. So anyway, that's really cool. Um, there's a bunch of others. Let's see. Let me just go through real quick with you because take is interesting. There's some neat things you can do with that. Sum and max and min it'll do for you, so you don't have to write that boilerplate code all the time. Assuming that it has an element that can sum. I mean, that's a cool thing. Like with sum, normally, I mean, if it would be easy to do one if it was just like a list of integers, but with sum, you can do this where x dot energy, so you can go through and sum the energies of every element in this list. You know, that's kind of nonsensical, but um, and obviously you can't assign that to a list output. But anyway, sum, last or first or default is nice. You're trying to determine if there's an element. You're trying to get the first element in the list that meets a certain criteria. So for example, first or default, the energy equals 6. So this will return the first element in the list that has energy of 6.0, and the default is null, so it will return null. So then you could do something with that. So output factor table or var. var is I don't really like to use it. I'm kind of old school Java type guy, but output factor table. Var basically um, you know, uh, interpolates what the type is. Um, so we would grab, well, let's see, we'll call it y. So in this case, if y equals null, then you could do something like console.writeLine. The console isn't very helpful. Message box dot show no 6x beam found, that kind of thing. But first tree default's nice because it will, return null if there's nothing that matches the criteria you gave it. So I think those are kind of the main ones. Let's look for this. I'd encourage you to kind of poke around. Element at, you can find the element at a certain index. Contains can be nice. Average. Yeah, I think those are. Zip actually you can use to like combine two sequences. So I've used zip, for example, if I have two parallel lists. So one is the age. If I have two lists that are 10 elements long, one is the name of the person's name and one's the age. I wanted to sort both lists by age. Zip can actually accomplish that very elegantly. So anyway, I think you get the idea. So I'm gonna undo all this stuff that I just did by holding down Control Z. It keeps track of everything you do for quite a while, which is nice. I was demonstrating, so now I'm back to where I was. So I think that's a good overview of things I was going to show you. Let me see if there's anything else. Oh, unit tests. Yep. So unit tests are important because they're really a great way to know if your code's working right. So in this code that I'm going to, of course, give you the access to the repository on Bitbucket. The sample is a good way to look first. So, obviously I have an NUnit framework. Using the NUnit framework, remember control period if you don't have something, class is missing, and remember your NuGet package. But basically, also if your tests don't appear in here, like contact me because there's something goofy that can happen, especially if you have lots of projects where it doesn't show up, and I can maybe walk you through a solution. But anyway, so from hard to easy, or easy to hard, so you can write tests. The general principle with unit tests is to follow a certain pattern, to arrange um, your system under the test in a way that it's ready to go. In this case, it's just a silly example. Test 1 equals 1, test 2 equals 2, expect equals 3. Act range, act, and assert. Those are the three things. So you do the thing that you're trying to test. In this case, I'm testing addition apparently, and then I'm trying to assert. So this assert function or assert class is part of the NUnit framework, but you can assert all sorts of things. It's not a number, blah blah blah. Usually it's like are equal because you have an expected value and an actual. But there is also something cool you can do with a delta if there are doubles that you're doing. You can tell it I want it within that much precision because there is some rounding error that you often run into, right, with doubles, floating point arithmetic, and multiplication, division, etc. This one test case, instead of using test, you can accomplish the same thing by, or kind of, you can arrange your test case a little easier, potentially, by doing um, test cases. So in this example, this function that I'm adding is a test case. The naming convention, by the way, should be the name of the class and function that you're testing, and then underscore the outcome, expected outcome, underscore test or something like that is usually what we do. So this isn't actually showing the best naming convention. Naming conventions are important. I'd really recommend trying to follow them as much as possible. I don't know if this one is a better example. No, this isn't a better example. Sorry. Yeah. Anyway, so test case, yeah. So these are passed in. 1 is passed in for test 1. 2 is passed in for test 2. Expected is 3, and all it does is assert that it works. Like technically, I should probably have brought it out to act and assert, and the act would be to add them together like it did above. So anyway, just to give you an example. Then test case sources, if you want, there's oftentimes where you want to test objects or structures that are more complex and can't be initialized by the compiler. So you have to call their new constructor, right? And so to do that, you need to use this test case source. You pass in, instead of like all these variables, you pass in the name of the test case source, and all it has to do is have this private static array of objects. And you can initialize arrays in C# by these brackets. Obviously, it has to end in a semicolon because it's a statement still. If this was like a number I was initializing, it'd be like that, but instead it's an object list or an object array. And so inside the object array, objects can be anything basically. I could have 5 and 6 in these objects if I wanted. But anyway, for test cases sources, you do arrays of objects inside of this array of objects, and basically every array of objects inside this list or array of test cases, because an array of object is an object. Everything's an object in C# or can be treated as one. Though there's some overhead for treating primitives as objects, but anyway, it can be treated as objects. So you can see here, if I go to the Test Explorer, this test example test case source has 2 entries. You can see the first entry is 100010001 because it's as if I had these test cases, but I was passing in these vectors 100010 and then 001, and then they're passed into these 3 parameters. So 100 is vector 1, 010 is vector 2, the expected value is 001, and all the function is doing the cross product and checking if it's equal. You can make, obviously, test cases as complex as you want, but the simpler, the better. The more focused they are on specific functionality, the better. So anyway, as you can see, it's a really good way to write code to test what you're doing. If you can write so I'm going to show you actually data point lists. So these aren't the greatest examples because I actually wrote these tests. The better thing to do technically with a paradigm called test-driven development is to develop your test first, actually, and then write the code that makes the test fail first, and then write the code that eventually makes it succeed in all the cases it needs to succeed. You should have test cases for every corner case, in my opinion. Anyway, so there's an interpolation test these are data point list tests. So my data point list does a lot of things. It does interpolation. It finds the data point list is a 2-dimensional or a list of 2D points, right? So if it's sorted or can sort itself by X value, so it has it can be a profile, but the profiles might have different spacing, so you can't assume that from each point to the next, each data point to the next, that it's 1 millimeter. It could be 1 millimeter once, and then 5 millimeters, and then whatever. So that's an important thing to know about these data point lists. So anyway, this one creates a random object, which is useful for getting the next double, which gives you, as it says when you hover over it, which is super nice, it returns a random floating point number from 0 to 1. So anyway, it gets a number basically from -500 because this goes basically -0.5 to 0.5 because it's subtracting 0.5 from it, multiplied by 1,000. So -500 to +500, and then the y value is just I. So anyway, it's just randomly generating these points with x values. It sorts the list, and then it goes through the min x is max x. One way you can assert that it's working or not is by throwing exceptions if it's not working. And if it is working, just don't do anything. You don't have to call any asserts if you don't want to. So this is a good way to demonstrate that. This basically tries to find the nearest data point to the next test, which is also a random number from -500 to 500. And if there is no number, then it better be outside of the range. If it's not inside the range, or if it's inside the range of the min and the max x, then it's going to throw exception, because if it's inside that range, there should be a nearest data point, or this function, which is one of basically the function I'm testing with this interpolation, or one of them. One of the functions I'm testing. So this isn't the best unit test because I'm testing multiple things in it, but it does give a lot of coverage to separate functions in its own way. So I mean, different paradigm, but whatever. So now it's looking for if the closest point, basically this point array, this get nearest data point returns an array of points, either 1 or 2. So there's one element in there, so that's what this closest 0 element is. If it equals next test, which means this is false because this is asking if it doesn't equal it, then we know that it landed right exactly, which probably never happened, but it landed exactly on one of the x values of one of the points in there. And so there's no interpolation that's going to happen. It's just going to use that point. But if it isn't, then it means that it's got 2 points in there, or should, and therefore it should be looking for whether or not the next test value, this x value that was randomly generated, is between the 2 points that were found as nearest neighbors. And that's what it's checking here. If it's not, then it's going to be like, well, and then it's going to check the interpolation. So it's going to look whether or not so it's going to interpolate the y. It's going to call the interpolate y function on these two points. And it's basically you pass in the 2 points and the x value, and the y value will be interpolated linearly. And so basically, yeah, it'll just check whether or not that interpolated y value is less than the y value in the first point, and if it is, it's just, yeah, basically just going to check whether it's appropriate or not. It's got to be less than, yeah, it should be inside the range of the 2. That's all it's testing. It's not actually testing exactly if it was interpolated correctly, but it's testing if it's in the range. The sort test does this random numbers, does a sort, goes through each element in the list, iterates over the list like this, and keeps changing the max to the list value. But if it encounters a list value that's greater than the max it's encountered, the max x, then it's not sorted correctly. Nearest data point test. Yeah, let's see. Oh, so these specific test cases. So this is one where I'm not using random numbers. I'm using exact numbers. I have a test x, expected before and after points. I know exactly what's going into the list, and I know exactly what the output should be. So some examples. So that's unit testing, and I'd really encourage you guys as you're developing to do unit tests. Really it's I've had a number of times where I just saving my bacon, especially for computational code that doing ray tracing and calculations and stuff that if you come up with these test cases, what the input is, what the output should be, it'll save you a lot of trouble. And you can actually debug these. Like if I put a breakpoint in here, come to the Test Explorer, and I run all, um, it'll, or it should debug. Oh, it failed on one. It's not run all. You got to run the one that you want. Test interpolation test. Right click on it, debug, selected test, and it's going to pop in here. And you can step through and actually see what's happening. Oh, did I tell you about these locals variables? You really should look at this tab. So you can see all the variables that this function has access to. They're local variables. So anyway, you can actually inspect what are the elements in this test list. As it's going through and adding these elements to this test list, you can see that count is going up. I'm holding down F10 to just keep going through the steps. And you can see all these test points, these X and Y values and these points. If I drop a breakpoint there and press F5, so it travels all the way to there, and I've got 10,101 10,101 entries, and that's my num times is 10,000 plus random up to 200, so that's what it got to be. But yeah, you can actually inspect it and see, oh yeah, it looks pretty sorted. Looks like the X values are sorted, so really good way to look at stuff. So hopefully this has been useful, worth your time to view. Again, I think those tips for Visual Studio will get you a long way. Hopefully save you a couple hours here and there. So yeah, and if there's ever trouble, like you can't figure out why it's not working, there's some gotchas, and I could help you out. I'm sure Kurt could help you out too. But yeah, hopefully this gets you going. So take care.